afternoon, everyone. Today I am presenting the third lecture on method of least squares. Earlier we have discussed the curve fitting for straight line exponential curves. Today we are going to study for few more curves. We will discuss the fitting of various curves and questions related to them. First of all, we will discuss about the curve y equal to ax to the power b. Earlier we have seen for exponential curve, we have taken the log on both sides so that we can convert it into an equation of a straight line. For this curve also, we will do the same. We will take log on both sides so that left hand side we will get log y log a plus b log x. We will assume it as an equation of a straight line, that is y equal to a plus bx, where capital Y will take the role of log y, capital A log a, b will remain as it is, and capital X will take the role of log x. As we know that the equations, normal equations for straight line are summation y and a plus b summation x, and summation of xy, a summation x and b summation x square. We will put the values of these summations from the given data and solve the equations to get the values of capital A and B. So that, and we can put the values of capital A and B to get the values of small a and b and substitute in the given equation. Likewise, we have another curve, that is AB to the power x. Similarly, we will take log on both sides for this curve also, that is log y log a plus s log b, so that we get it converted into an equation of a straight line, that is y equal to a plus bx, where capital Y will be treated as log y, capital A log a, and capital X will remain as it is, and b will take the value log b. Same as the normal equations of straight lines are given by this, we will consider these two normal equations. From the given data, we will put all the values and solve the equations to get the values of capital A and B. In the end, we will substitute small a. We can get the value of small a by antilog of a and small b by antilog of b. Now we will consider some questions to get this concept clear. Here is the first question. Obtain a relation of the form y equal to ab to the power x for this following data. This data is provided to me for x taking values 2, 3, 4, 5, 6. I have the corresponding values of y. We need to fit this data in the curve y equal to ab to the power x. As we have discussed, we will take log on both sides so that log y will take the value log a plus x log b, and we will get equation of straight line in this form. Now we have to find the value of capital Y. We will replace capital Y by log y, capital A by log a, x will remain as it is, and b will take the value log b. So the normal equations for straight lines are given by this. Now to find the values of capital A and capital B, we need to solve this values from the given data. So let's see, we can calculate these values from the given data. Capital X is remaining as it is, as we have seen earlier. And we have to choose capital Y as log Y. So capital X will take the value x as it is. Capital Y will take the value log Y, so that we can find x square and x into y. So these are the corresponding values of x, y, log y. We can calculate it from the calculator. Then we have capital of x square and capital X into y. Now, to solve the values or put the values in the equation, we need summation of x, that is 20, summation of y, that is 7.5455, then summation of x square, that takes the value 90, summation of x into y, that takes the value 33.1812. Now we will put these values in these normal equations. Summation y, that is 7.5455. Total observations are 5. So 5a plus 20b. Then summation xy, 33.1812 that is equal to 20A plus 90B. So we have these two normal equations now. Equation number 1 and 2. We can solve them by cross multiplication method, or simply you can multiply equation 1 by 4 and we will get the corresponding values. On multiplying the equation number 1 by 4, we will get B as 0.3 and on putting the value of B in either of these equations, that is equation number 1 and 2, we will get A as 0.31. So after getting the values of A and B, we can find the corresponding values of small a, which is antilog of A. That comes to be 2.04, and small b, which is antilog of B, which comes to be 1.995. So we got the values. Now put these values in the equation, that is 2.04, 1.995 to the power x. So this is the best fit for the curve y equal to a b to the power x. Similarly, let us consider another question, that is fit a curve y equal to a x to the power b to this following data, where x and y are given. X is from 1 to 6 and correspondingly y is given. As we have discussed, we need to fit this data in this curve. To fit the data in this curve, we have to take log on both sides. That is, we get log y, log a plus b log x. We will represent this in equation of straight line, that is y equal to a plus bx, where capital Y will take the role of log y, capital A log a, b will play the role of b only, and capital X will take the value x log x. So the normal equation for straight lines are given by this. We will consider these two equations. Now we need the values of these terms, summation y, summation xy, and summation x square, so that we can solve them and get the values of a and b. So we get these values from this data only. Let us see. Capital X is taking the value log x. We have found it from the calculator. Capital Y is taking the value log y. We can calculate it from the calculator. We can get xy and x square from the data. Now put these values in the equation. For that, we need summation x, which comes to be 2.8574. Summation y, which comes to be 4.3133. Then summation of xy, which comes to be 2.2671. And summation x square, which comes to be 1.7749. Now, on putting the values in the given equation, total observations are 6, so n will take the value 6. 2.8574b. Then we have 2.2671, which is equal to 2.8574a plus 1.7749b. Now, since the terms are pretty large, we can solve it by cross multiplication method. That is a, b, and in the end, we will consider the constant term 1. So a will take the value 1.1777. B will take the value 1.2778. And third, for constant, we will get this. So now we can equate this A with 2.4847 and get the value of A. So on solving, we will get A as 0.474 and capital B as 0.5143. Now, as we have discussed, we can take the antilogs. So small a will take the value antilog of this, which is 2.9785, and B will take as it is of capital B. So my curve will be 2.9785 into x to the power B, that is 0.5143. This is how we can fit the data in x to the power B. Similarly, we have one more curve. We can have plenty of curves like this. So I'm discussing one more curve, that is y equal to ax plus bx square. As we have done the method of least squares earlier for straight line, for this also we will solve and find the normal equations in the same procedure. We will consider the error for this, that is sum of errors. Error will be y minus ax minus bx square. Now taking the sum and considering it square, we can solve it by method of least squares. On solving by method of least squares, that is del u by del a equal to 0 and del u by del b equal to 0, we get these two normal equations for this particular curve. That is summation xy a summation x square plus b summation x cube, and summation x square y is equal to a summation x cube plus b summation of x to the power 4. So let us consider one question regarding to it. By method of least squares, find the curve that best fits this data, where x is from 1 to 5, and we need to fit this data, that is y equal to ax plus bx square. As we have discussed, the normal equations for this curve are given by this, which is slightly different from straight line. One x extra is over there. So we can find all these values from the data, and then we can find the value of small a and small b. So let us consider a table x, y. We can find all the values x square, x cube, x to the power 4, xy, and x square y. On finding these values, then summation of x will take the value 55, summation of x cube, this is summation of x square, summation of x cube will take the value 2 to 5, summation x to the power 4 will take the value 979, summation of xy will take the value 194.1, and summation of x square y will take the value 822.9. Now we need to put these values in the said normal equations, that is summation xy plus summation of xy, that is 194.1 equal to a summation x square, that is 55a, plus b summation x cube, that is 225b. Then next we have summation x square y, a summation x cube, and b summation x4, that is summation x square y 822.9. Then we have 225a and then we have 979b. Now we need to solve these equations. You can use either of the method. Either you can multiply equation number 1 and 2, or you can do the cross multiplication. By doing so, you will get the value of a as 1.52 and value of b as 0.49. So my curve will be 1.52x plus 0.49x squared. This is the best fit to the data. Like this, we can solve several curves to get the best fit for the given data. These are the references you can consult. Thank you.